So up to this point, you know how to define a variable. You also know what an expression is. You know what an operator is. You know what concatenation is. A whole bunch of different terms that we've learned in this little section of the course. Another term that I want to give you is the term declare. So declare is another term we use for when we want to define a variable. So we could say define the variable username. We could also say declare the variable username. So we either have a definition or we have a declaration. So those are the two terms, and they're interchangeably used. So you need to be able to recognize both of them. So now that we know how to do this, we need to be able to figure out how to store values inside of those variables. So just going back over to OneNote, I'll give you a quick little example, a few things here. So if I were to write the value or the expression x equals 5, you would know that x has the value 5. It must, because mathematically speaking, the left side must equal the right side. That's what equality is. Which means we could also write 5 equals x, and that is functionally the exact same thing. Now in programming, we can't do that. It doesn't work like that. We have to follow our syntax, our grammatical rules. And if we could go both ways, we'd be in trouble because it would be ambiguous, and C# wouldn't know which one to use. So it says, let's set up a standard syntax and follow that standard syntax. And the syntax that it uses is very simple. It's identifier, which we know is the name of a variable, use the equal sign, and then an expression. And the way we read this is we say assign the result of the expression to the variable in memory which is noted by the name identifier. So whatever identifier actually is. Now I notice I used the word assign. I didn't say equals. I can't say identifier equals expression because it's not the same thing. That's mathematical. In this case, this is our programmatic way of saying it, where we're using the term assign. Essentially that means put whatever the value of expression is in memory. Where in memory? Well, wherever identifier has its reserved space. So to make sure that you get this straight in your brain, we always want to go like this. The value that we want to store is always on the right hand side of the equal sign. The location in memory we're going to store it in is always on the left hand side of the equal sign. Oops. So location on the left, value on the right. So let's do a quick little example. I'm going to create a quick variable here, int num. And num is going to be short for number. And what's going to happen here is when we do this, it's going to go over to memory and try and find someplace, the first block of memory that can store an integer variable. So it has enough space for an integer. Well, let's say it gets right up at the top. We're going to call this num. Now we can actually start using our assignment statement. So we could say num is equal to 5. Now we don't actually read it like that though. That's mathematical. We say assign the value 5 to the memory location that is identified by num. So it'll go over, find where num is, and store it right there. So it's done. It's there. So we can now use it however we want. So for example, we could output it. Say console dot write line 5. No, sorry, 5 is not what we want. We will actually want to use the variable. The variable is of course num. So what's going to happen here is it's going to go off into memory because it needs to evaluate this and say, okay, well, what is the value of num? It's going to go into memory and says, oh, the current value stored at the variable num is the value 5. So 5 comes back and is substituted for the word num, and then the expression or the statement is actually carried out. So 5 is written on the screen. Now you remember from previous lessons that in console it's okay to have an integer or a number inside of a console.write line, but in a Windows Form program we can't do that. We have to make sure that it's actually a string. We'll get into more detail on that later, but for now just treat it the way it is. So I mentioned that we could put an expression on the right hand side of the equal sign. So we could do something like this. Num is equal to, let's say, 5 times 2 divided by 3. And the way that's going to work is it's actually going to go through and do all the math first. So it's going to follow the rules of mathematics, BEDMAS. Say, well, 5 times 2 is 10. 10 divided by 3 is about 3.1 or something like that. But the problem is num is an integer. So what happens to the decimals in an integer? They get truncated. They're cut off. So 3 point whatever just becomes 3. So when we have this, this results in the value 3. So 3 is then replacing the value 5. The 5 is now gone. It no longer exists. So what we're going to do from here is we're just going to back that up a second. And we're going to get rid of this statement just to show you some other things we could do. We could actually store other variables in there if we wanted to. So for example, let's say I had another variable. Let's say int num2. And we say num2 is equal to 3. So over here, we have another variable, and this is num2. And it has the value 3 if we follow our program in order. Now I could just as easily say num, assign to the variable num, the value num2 times 3. So it's going to evaluate the right-hand side of the equal sign first. So it evaluates the expression before it does the assignment. So it says, okay, goes over to memory and says, go get me the current location or the current value stored at the variable num2. Comes over, it says, well, that's a value of 3. So num2 gets substituted with the value 3. So then we have 3 times 3, and this whole thing results in the value 9. So now 9 then replaces the current value stored at num. We come up, 5 gets deleted, and 9 replaces it. So what we have here is a variable using a variable. That's just one example. Another thing we could do is we could actually use the variable on itself. So for example, I could say num is equal to num plus 1. Now you might think, well, how is that even possible? How could you do that? Well, you got to remember the order that things occur in. The right-hand side of the equal sign is completely evaluated to a value before the assignment occurs. So that means when we do this, it's going to say, okay, well, what's the current value of num? Well, we go over to the memory and you say, oh, it's the value of 5. So we have 5 plus 1, which is going to give us 6. So then it says, okay, assign the value 6 to the memory location identified by num. Comes over, says, oh, sorry, you're gone. You're now the value 6. There's a very special term that we use when we add values to a variable on itself. So num equals num plus 1. The term for this is increment. We say the variable is incremented, in this case, by 1. You might have num equals num plus 4. And that would be the variable is incremented by 4. And of course, if there's an increment, there must be a decrement. Decrement goes the other way. So it means that instead of adding, we might have subtract. So we have increment and decrement, adding and subtracting on a variable to itself. There's also shortcuts that exist for this because this is such a common thing that's done in programming, C# and many other languages. So instead of writing num is equal to num plus 1, the shortcut is just num plus plus. And that will mean the exact same thing as assign the value num plus 1 to the variable num. So of course, the opposite of that, to decrement num, is num minus minus. So these are very useful tools, and it will shorten down your work quite a bit when you get into more complicated things. So just quickly jumping over to C# itself, where do we actually define our variables? Well, the place that we define our variables, I told you before that we'd always be working down here, but we'll also be working here. Right here, right below the class line, this is where we define our variables for now. Later on, we'll change that, but for now, all of your variables will be right here. So for example, I might say int num. And then I can't do any